Namaskar, I am Dr.suresh and in today's class we are going to discuss about solver. This is chapter 9 of data analysis tool uh, of business data analytics book. So before going for solver we have to know that it is related to linear programming and thus you should know what exactly linear programming is. So linear programming or linear optimization is a technique that helps us to find out the optimum solution for a given problem. An optimal solution is a solution that is best possible outcome of a given particular problem. If we'll go for the example, I'll directly go to the example. Oh, okay. This linear programming problem is applied in basically three situations. One is or three uh, problems. One is manufacturing problem where the goal is to maximize profit or minimize cost. Second one is for transportation problem for minimizing the transportation cost and optimum assignment problem. There are two methods. Basically, one is simplex method and graphical method, which is used in linear programming problems. If we'll see this example, Smaran holds two part-time jobs, job 1 and job 2. He never wants to work more than a total of 12 hours. He has determined that for every hour he works at job 1, he needs 2 hours of preparation time, and for every hour he works at job 2, he needs 1 hour of preparation time, and he cannot spend more than 16 hours for preparation. If Smaran makes rupees 40 an hour at job 1 and rupees 30 an hour for job 2, how many hours should he work per week at each job to maximize his income? Okay, so see how this question will be solved. We'll go for the initial solution, or what you have to do is that see, uh, let number of hours per week Smaran will work at job 1 is X, we're assuming this, and number of works Smaran will work at job 2 is Y. So if we'll see this first constant is that uh, he will be getting 40 rupees from job 1 for each hour and 30 rupees for job 2 for each hour. So if you're going for that, so it will be I means the income will be 40 into X plus 30 into Y. Hours spent in job 1 is X, hours spent in job Y is job second job is Y. So his income will depend on how much hours he is working on job 1 and how much hours he is working on job Y, and accordingly he will be paid 40x into 30y. I hope it is clear. Second constant is that uh, he never wants to work more than a total 12 hours a week. So in job X and Y altogether he will be working only 12 hours per week. So X plus Y should be smaller than equals to 12. So this is the constant. This is our objective. This is I is equal to 40x plus 30y is the objective function, whereas the constant function is x plus y is smaller than equals to 12. Another constant is that for each 1 hour of work in machine X, 2 hours is preparation time. It has been given. Okay, he needs 2 hours for preparation time for every works in job 1. So and that for every works for job 2 1 hour, he requires 1 hour of preparation time, and he cannot spend more than 16 hours for preparation. So 2x plus y is smaller than equals to 16, and obviously x and y will be never negative, so x and y is greater than 0. So there are three constants. One is x plus y is smaller than 12 smaller than equals to 12, 2x plus y is smaller than equals to less than equals to 16, and x and y are both greater than equals to 0. So this is how you'll be getting the statement regarding the objective and the constraints. So now we'll go for the solver. Okay, how it will be done. See, this is the process of installing solver in MS Excel. Okay, now see, it has been given the optimize total shipping cost, the following constant must be set. There are three plants of a company, plant, and each plant must produce at least 200 units a quarter to justify remaining open. That means every plant needs to produce at least 200 units per quarter. That is the minimum. Plan 1, 2, 3 has maximum capacity of 90, 920, 450 and 550 units respectively. So they cannot produce more than that maximum capacity. That is one constraint. Okay, the plant production must be equal to the requirements of the warehouse, since there is short shelf life, as the product is having short shelf life. So as per the requirement of the warehouse, the plants are required to produce. Note that the shipping cost vary because plant locations, and that this is factored in the total shipping cost. Okay, obviously, shipping cost per unit is 125, 184, 145. That means plant 2 is much more distant from the location, main location. That's why this is, or from the warehouse. That's why the shipping cost is more in 184. The nearest one is plant 1. So with this objective, we want to minimize the total shipping cost. So how much to be produced? Obviously, if you'll produce or supply from plant 1 where the shipping cost is less, then it is better compared to plant 2, because if you supply material or output from plant 2, the shipping cost will increase. Now how to do it? Okay, so see how to do it. uh, I'm just erasing this one so that it will become easy for you. Okay, now see, first, you have to write plant 1, plant 2, plant 3, total units produced. Here you have to write quarter 1, quarter 2, quarter 3, quarter 4. Shipping cost you have to mention, then total shipping cost. Okay, remember that you have to make formula. 0, how it is 0? It is sum of B5 to B7. Means first quarter of plant 1, plant 2, plant 3. If it will be added, then total units will be produced for first quarter. Similarly, second, third quarter and fourth quarter. Remember that suppose whatever quantity you will be producing in first quarter, second quarter, third quarter and fourth quarter. So how you'll be getting this? You'll be getting 125 is the shipping cost. So 125 into quarter one's supply, 125 into quarter 2 supply of plant 1. So accordingly we have put the formula here, 125 into B5, 125 plus 125 into C5, because from plant 1 the shipping cost is 125, so you'll be multiplying the output produced in plant 1 with 125 for each quarter. Similarly, for plant 2 you'll be multiplying 184 with the production of first quarter by plant 2, then 184 into second quarter of plant 2, then 184 into like this. So you'll be getting this value. So I will go for solver. See, once you have installed server in data, it will be shown here, solver. So click on solver. I have already set it, but remember how to do it. Okay, I am deleting all this. uh, Reset all. I am resetting all. Okay, see, so our objective, first objective is that you need to find out total cost. total cost of shipping. Okay, and this is minimizing the total shipping cost, so it will be like this. So first is total shipping cost minimize. Okay, by changing the value variable cell, we can only change this portion. So this is, then you have to add the constant. First constant is that first constant is that uh, minimum this plant has to produce 200 quantity per quarter. So this should be less than, no, should be more than equals to 200. Okay, this is the first constant. That means each plant should produce more than 200 quantity every quarter. Okay, B5 to E7. Second, that plant 1 every quarter, okay, should be, the production should be less than 920. That is the maximum quantity. You cannot produce more than 920. So this is one constant. Second is that, second, the second plant cannot produce more than 450. Okay, and third plant third plant cannot produce or 550, 550, probably 550, 550. Let me check it whether 550 or 920, 450, 550. Okay, that's it. And last constant is that total units produced. This should be equal to, okay, should be equal to this. It has been one of the constant that total units produced should equal to total demand, okay, or warehouse demands. Okay, you have to click on add and cancel here. So see, we have set the objective by changing variable. We have set the constant. What you have to do is you have to click on solve. Once you click on solve, keep solver, and then okay, you'll see this. That means that means you have to produce 920 from, in quarter 1 you have to produce 920 from plant 1, 330 from plant 2, 330, 550 from plant 3, to make a output of 1800, which will be equal to the warehouse demand. Okay, similarly 800, plant 1 400, plant 2 200, plant 2 3 200, it is equal to. And so total shipping cost, how it has been calculated, 125, the formula we have applied, similarly it has been calculated. So 125 into 920 plus 125 into 400 plus 125 into 920 plus 125 into 920. So it is the result of 3900, 3,95,000. So if you add all the shipping cost, you'll be getting this value. So I hope it is clear. So it is very useful tool if you are going for a linear programming problem in Excel. I hope it is okay. Thank you. Thank you.